So good afternoon, everyone. I hope you're enjoying your DevOps so far. We're going to talk about caching and mostly focusing on the JSR-107 javax.cache and also Ehcache 3 as an implementation of it. So first of all, an agenda, and I'll start from the beginning. Why a cache? Then we'll look at JSR-107, both from the APIs and features point of view, which is what's going to interest you as developers, and explain a little bit what kind of extensions provider can offer. Then I want to cover caching in the context of an application, because when you work on a caching product, you end up knowing a lot about how to use the product and what's best for it. But when you talk to developers, you realize that often they really use it with the initial view on it. And so the idea here is to give some thought or food for thought so that you can go deeper into using caches inside your applications. And then I want to talk about something special at the end, which is what we're trying to do with Ehcache 3, and which I think is of interest for developers' application and what you present to your users. And that's going to be called resilience strategy. And a few extras. So, quick, who am I? Louis Jacomet, I'm a software engineer, closer to the 14 and the 20s. I work at Terracotta since 2013, and I've been mostly working on Ehcache, both the open source and the enterprise features. I'm not a UI guy, clearly not on the web at all, but I rather enjoy concurrency, thinking hard about problems, APIs, that kind of stuff. And that's it. Except hearing me talking, we won't talk about me anymore. So, why a cache? That's titled Latency Numbers Every Programmer Should Know. You may have seen that appear in different contexts, on the web, in presentation, all over the place. It has nice shiny graphs, and it's pretty hard to read, even on the big screen. So, what were these numbers? If we expand them to think in time we can understand, we start with a minute. And L1 cache access in a CPU, it's half a second. It's kind of a heartbeat. Then we can go over that. So we go to the L2 cache access, 7 seconds. Already a long yawn, it's nearly an order of magnitude more. Then if we move to the hour, we can compress 1K. That's actually the length of a TV show. Moving further, you actually want to send 2K on a 1 gig network, it's your work afternoon. Even more, random read on an SSD, a weekend, sequence read 1 megabyte from an SSD, 2 weeks. You know that delivery you've been waiting for? Yeah, that's the time it takes, well, or took, depending on how fast your provider is. Really more than that. Sequence read 1 megabyte from a rotational disk. We go to nearly a baby. So we left the L1 at a heartbeat, and now we have the time to get a baby. And then when you want data to round trip around the world, you have the time to do a PhD thesis for that. So this gives you an idea of the magnitude computer systems deal with. And so in that context, what's a cache? Actually, the L1, L2, and other stuff were already caches. And so a cache is a data structure that holds a temporary copy of some data. And the temporary is important. It's a trade-off between higher memory usage for your application in order to benefit from reduced latency. You don't have to fetch the data across the network. You don't have to fetch the data on disk. Which means it targets specific data. You better have to reuse that data, otherwise the memory trade-off is for nothing, or the data should be expensive to compute or retrieve. Probably not worth caching the result of a basic math operation, because the CPU might be faster at giving it to you. So in this context, we've got Ehcache 3, which is a caching product. The new version is fully integrated with JSR-107. It's still under active development, and it breaks compatibility with the 2x line in order to offer a modern API. It's developed in the open, so it's fully open source. You can find the code on GitHub, the issues on GitHub, the conversation about the issues happens on GitHub. And we also host a public dev meeting almost weekly, usually on Thursday, 8 p.m. European time. And the recordings are available on YouTube. Might not be the most exciting YouTube video you've ever seen. Probably is hardcore sometimes, or most of the time, I should say. But if you're interested in the kind of thinking that go through into doing a cache product, it's interesting. And if you have feedback, it's of course very welcome. So now that we've set the stage, I'm hoping that's not like brand new news for anyone. But if you have questions, do not hesitate to interrupt in the presentation. Let's have a look at the JSR-107. So JSR-107, it's actually, if you know that GSRs are numbered in order, it's a pretty old GSR. So it started back in 2001 and got approved a year ago. It probably benefited from the fact that the JCP didn't have strict policy about closing down inactive GSRs for a long time. But yeah, it's there now. It's clearly an API, the javax caching API. It's a TCK, so the toolkit for compatibility testing. And it's a reference implementation, a basic cache system that you could use as is and will respect the spec to the letter. And clearly the goal of offering a caching standard is to ease the integration of caching in frameworks, but also in your applications. You may have more chance of switching a caching provider than switching a database, because it's different layers, and so that's one of the offerings of JSR-107. And if you follow the mailing list, you'll see that there are ongoing discussions, either on the mailing list or on GitHub, actually, about a version 2. And one of the things that's considered for the version 2 is potentially an async API, so which would allow you to do caching operations, but not wait for the result. Features. The way JSR-107 organizes caches will sound familiar to Ehcache users because it has the concept of a cache manager, which is something that can deliver caches to you. And then it has the concept of a cache, which is the data structure you actually get and put from in order to put data in it and retrieve it using get. It has the concept of expiration. So an entry in the cache can expire, and the expiration can be based on the creation time of the entry, its access time, or when it was updated. So this gives you different expiration patterns to rely on. It has an integration specifics, which allows you to have cache loader and cache writer being registered into the cache, and we'll see how these play into the kind of caching patterns we can do later on. Cache entry listener, so these are listeners which will be fired every time you interact with the cache by creating or updating an entry, removing or expiring that entry, or the entry being expired, I guess. And one of the thing that the specs allows is that you can actually get the old value. So when you have an entry that's updated, you can request, when you configure the listener, and say, oh, by the way, when an entry gets updated, I want to be warned, I want to get an event, but I also want to get the old value. This is optional. Does that make sense to anyone, the fact why it's important it's optional? Exactly. You don't have always locally the old value when you update. If you've got a cluster distributed cache, you probably don't want to pay the price of fetching the old value from a different server when you're actually replacing it. It has the concept of entry processor, which allows you to apply a lambda on an entry. The API is not Java 1.8, it's actually 1.6 compliant, but clearly I can use the word lambda. That means everybody understands, and it means in 1.6, 1.7 you can use a single method interface, which is what the signature of that method takes. It has a number of annotations that allow you to declaratively configure caching on your methods. It exposes a number of mbeans. which gives you access to the configuration of the caches and to the statistics. And this can be tweaked per cache. And that's it. Anybody sees the missing bits when you think about a cache? Or the big missing bit? There is no capacity control, which means that without looking into provider extensions, you have no way of saying that the size of your cache is limited. Well, it happens most of the time. Memory on the machine where the application runs is really limited, physically or even by other concerns such as the garbage collector. So that's interesting. They also don't talk about topologies, but topologies do come through, for example, the old value being optional, the fact that by default in JSR-107, when you put stuff into a cache, it's by value, which means the value will be serialized and deserialized so that you're sure if you mutate the value outside of the cache, what's in the cache is not changed. And the reason that this is the default is because that's the only behavior you can have as soon as you talk about clustering or distributing your cache. On the JVM locally, when you store everything on heap, you can have by reference entries in the cache, and if you've got immutable data, that's probably the most efficient way of getting it there. But as soon as you move to larger topologies, this is not a possibility anymore. Why? The company I'm in will tell you that it was a possibility, but it no longer is. So that was kind of the business of Terracotta with distributed server objects. So I think the easiest way to go around the caching API is just to have a look at how it works. Oh, so that's interesting. Okay. So the way you get to a caching implementation is by using the caching get caching provider. And so this is code that's contained in the spec, and it will use the service locator pattern to load the caching implementation you have on your class path. If I do it like that, it's going to load the default one. Otherwise, I can actually find the default one, meaning the first one it finds. Otherwise, I can specify the one I want. And so you can actually use multiple caching implementation in the same application if you need to. So this gives me a caching provider. Is that still readable? Yes? OK. So once I have my caching provider, I can actually get cache managers out of it. I'm going to use the first one, the default, but otherwise you see that you can actually specify a URI and class loader, or even URI, class loader, and properties to get a specific cache manager. We'll come back to the meaning of these in the context of providers. And so once I have my cache manager, that's it. I'll need to configure caches, but I'm just going to move initially to just getting a cache. And I'm going to get, so this is going to be the cache name. And then I probably want to pass in the type of the keys and values. So it's a 1.6 API. It's generified, which, for example, wasn't the case for Ehcache 2x. So I've got my cache, and clearly here what I can do are the basic operations. So if I want to put something in it, the system will help me. So that's not valid because wrong type. And that's it. I've got an entry in my cache. Then the opposite operation is, of course, I'm just going to get it. OK. And so these are the basic operations. Of course, you also have more you can remove entries from the cache. You can actually close the cache, which means you're no longer using it. And you can also, of course, come on, what's the? So you've got also all the CAS operations like put if absent, replace by comparing the value, And then you can invoke, that's it, sorry. You can invoke an entry processor. So an entry processor is what? It's a single app, an interface with a single method process which will pass you the mutable entry. So it's an entry that represents the content of the cache, so it contains both the key and the value. And whatever you end up mutating it to inside this method is what will be in the cache once the entry processor has been applied. And it also offers, so you need, for example, to do mutable entry, set value, like that. And so that's going to be mutating the entry itself. And then you can return something which is also part of the signature of the method. And that's what you'll see as the result of the invocation. Okay, so pretty basic stuff. This, of course, is kind of a nice way of doing advanced mutation of cache entries while making sure that providers will make sure that this is like under lock scope, so properly, not necessarily locking, but at least properly isolated in case of concurrent code. So you're sure that nobody else is mutating that same entry while you are doing it. The spec also offers a way to configure caches. So you can create a mutable configuration. Let's make it long string. And so that gives you a configuration. However, remember, Java erasure kicks in. So even though we specify the type of the configuration here, you should always call set types, which the type system will check that you do the correct thing. But so once you've done that, then you've got a mutable configuration object you can use. If you don't set the type, you'll have issues at runtime because most of the providers have no way of inferring the types of the configuration if these fields have not been set, because if they've not been set, they default to object. And so you may end up having conflicts either when you create the cache or when you actually use it. That's on the configuration that I can set stuff like statistics enabled, which then make sure that the mbin is recorded with the mbin server. And the mbin, you'll find it depending on the cache name you pass when you create the cache. So that's not part of the configuration. It's really when the cache is created by the cache manager. That's also where you can set the expiration policy. So everything is kind of factory based. So what you actually want here is a factory. So you need to use factory. Come on. Where are they? Oh gosh. There we go. Sorry. So for example, here it's an eternal expiry policy, which is the default. And so you'll find a number of them provided, but otherwise you've got kind of DSLE-like constructs to build a factory out of a custom expiration that you want to use. And so once I've got a configuration, the way I get a cache from my cache manager is by doing create cache. And there, what I need to pass is, again, a cache name and the configuration itself. And that, again, gives me a cache, which, once again, gets the proper type because it knows what types the configuration carries. Any questions with regards to that? Okay. So I've kind of shown you most of JSR-107. I mean, the rest is the details about configuring other features of it. And where's my XML? Like configuration using an XML file. Every framework has that. As it happens, JSR-107 does not. So the only option you have to configure it is by using the types that I've shown you, which is the mutable configuration, which is the object that comes out of the specification and which carries only configuration options known by the spec. So that means programmatic and only. So as soon as you want something else, which includes, for example, capacity control, you need to go into the provider's extension. And for example, one way of doing that with the Ehcache 3 is the cache manager URI can resolve to a configuration file, a valid Ehcache configuration file. And if that's the case, we'll load that file, and you'll have a JSR-107 cache manager that knows about the caches that you configured in that XML. But since you're kind of forced to go into the provider specifics for configuring your caches, because otherwise you've got no capacity control, we've tried to think a bit more about the different options we wanted to offer JSR-107 users when they use Ehcache as an implementation. And so just to show you the different kind of options we have, so let's assume I have a caching provider. I'm going to assume for the moment that I'm happy with using the Ehcache APIs inside my code, even though the rest, so inside the configuration bit of my code, even though the rest of my application code just relies on the JSR-107 defaults. So here I've got an Ehcache dependency. So the way I'm doing that is classically I just get then the default cache manager, probably works good for me. I'm going to do everything again in code. However, this time, I'm going to do a new cache configuration builder, which is the DSL approach to configuration from Ehcache 3. And on that builder, let's say that I want an expiry, and here I'm going to give it a time to idle expiration of five minutes. And then with that, I build my configuration, and let's say that again. What I have is, sorry, a long to string cache. So this gives me a configuration, but of course this is a provider-specific configuration. So now, I forgot to take my variable. So now from my cache manager, I can create a cache and pass it the configuration by wrapping it inside a known JSR-107 type. And so this is the way you get a programmatic Ehcache configuration into JSR-107. And internally, of course, we know that it's one of our types, so we can use it to configure more than the defaults. And so, for example, one thing I'd like to hide here is I want a resource pool. Come on. With heap, and I'm going to say 100 entries. There we go. And so here, this time, I've got capacity control on my cache, and so it's going to be a JSR-107 cache. And as soon as I go above 100 entries, eviction will start kicking in. And so least recently used entries or whatever the eviction algorithm is would start kicking out entries when new entries make it in. But you may not want that. So you may want actually to say, I want to use XML, and so then I have no Ehcache dependency in my code. I don't even have to put the dependency of the library under the the developer's control, so there is no chance that Ehcache code creeps in my application. And so then when I do that, the way I do it is by getting my cache manager. So I'm just going to cheat here to get to the resource. So this will give me the resource that's from my class path. And I'm going to use a caching provider default class loader. And so this gives me my cache manager. And this time, the only thing I have is the reference to the Ehcache.xml. And so what I would do then, if I'm able to use that pattern, I would simply have in my configuration file a cache with heap there. And that's, for example, a simple cache which will use the defaults for the rest, but will be loaded and have some capacity control. Oh, God. However, there is one feature in Ehcache 3 on the XML side, which are templates, which allow you to regroup cache definitions and not have to repeat what's common between the different caches. And we thought of a way of actually abusing templates when in the context of JSR-107. Because we could say that, for example, you inherit an application, or you have to use an existing application that uses JSR-107, and you don't want to touch the code. There is no, you can't recompile it anything. You can potentially pass parameters in at the startup, like VM properties, but nothing else. And so what we thought was, maybe we want to allow you to still define things around the caches. So let's say here that I have, again, my caching provider, the cache manager. So this gives me my cache manager. And here, for example, one thing that we do in Ehcache is when you load the default cache manager, we will actually look up a VM property, a system prop. And if that system prop is set, we'll assume that the default actually meant go load that XML file. And so it's a way to reintroduce an interaction from outside of changing code. So you got to that cache manager, and the way it was used was probably, again, new mutable configuration. And some other settings on that configuration. And the thing is, when you get to that bit of code which you'd like to slightly change the behavior of caches, or even extend the definition of these caches by actually providing some capacity control on them without changing the code, so you've got get cache manager, create cache, Ehcache with the configuration. And so the basic setup is I don't want to change that code. So like I've told you, I just pass the proper system prop, which gives me the absolute path to my configuration file. And in the configuration file, we have, oh, no, that's not the one I wanted. Sorry, that was the XSD. In the configuration file, we've imported an extra namespace, which is the JSR-107 namespace. So what we will do is we will define inside the Ehcache namespace some cache templates. And a cache template is really similar to a cache definition. And now, how do I link that template to the cache I've seen on the other side? I actually the whole concept of configuration in Ehcache 3 has been thought as modular and allow you to extend it with services. And we eat our own dog food, so that's what we did with 107. So we've added a namespace JSR-107, which allows us to give us a number of defaults. And so, for example, one of the defaults is in the context of JSR-107, I want a cache named something. And so I'm going to use a cache, which is the name I had on the other side. And I'm going to say that needs to be the default cache that I see down below. And the XSD is really helpful in that context because it will make sure that this is a known cache template ID. And so this means that in my code here, sorry about the scrolling, the cache I'm getting from here will have its configuration, which is provided through code, expanded. And it will also potentially, if you define things like expiry, so here the default expiry is eternal. So now if I'm in my extension, that's right. If I'm in my extension, I actually give a TTI, what's it complaining about? Sorry. Yeah, my bad. Like that. And if I give it okay, forget about that one for the moment. That's about it. But so this will then override the expiry of whatever was configured through code. And so we've thought that was a useful feature if you had to switch providers without touching the code. So again, if it doesn't make sense, let us know. But we're interested in knowing if that seems to be useful. So that was it for the code side. Any question, remarks so far? Yes?
Did you maybe ever encounter a situation when you have 10, let's say 10 gigabytes RAM for cache and not more, and you want to use it as much as you can, and you don't know the entry size beforehand?
Okay, so okay, so the question is about you've got an amount of memory, but initially you have no idea how big an entry is that you put in that cache.
And generally entries are different.
Also, yes. So two things. A general answer, that's probably something you want to find out, because when you go in production, you want to know how the system will behave. A second answer, Ehcache 2 and Ehcache 3 will have it, but it's not there yet in the code at this moment. We have what we called automatic resource control, which allows you to size your cache, even on heap, using memory units. But of course, this comes at a cost, because then it means that we have to dynamically compute the size of whatever object you put in there. And if you put a simple POJO that has mostly string and other primitive fields, that's probably going to be fast. If you start putting a set of sets in the cache, computing the size of it each time, because, as you've said, not all objects are equal in size, especially, then it's intensive. And so the entry count I've showed you here is actually not the most natural for a cache, but it happens to be the most efficient for a heap cache, because that's what really easy to compute. Oh, you've added one more element, I increment the counter. Oh, you've removed an element, I decrement the counter. And as soon as I do memory computation, it's more expensive. So, caching in an application. You probably have seen similar code somewhere. I've made sure to write it as scrappy as I could so that there is no doubt about how good code I can write. But so here the concept is you've got a business method, takes a number of parameters, all string, awesome. And what we do is we create a key from these parameters. We try to get that key from the cache. If we have nothing in the cache, we do some expensive logic, compute a value, put the value back in the cache, and return. And of course, if we add the result in the cache, we skip the if block and return the value directly, saving us a lot of CPU time, network time, whatever. Any thought on such code? It's not functional. It's functional, but it probably doesn't gain you everything you want. And indeed, it has plenty of problems. So yeah, this is problematic in multiple ways. You're starting an application, and you've got 20 users coming together. Here, you're potentially loading all the static data of that application. You'll load it maybe not 20 times, but probably 10. Because there is no flow control. Concurrently, everybody will just execute all the operations without ever looking at anyone else doing it. So cache aside is not so easy, but it's the most used caching pattern we see live in code. Technically, if you want that code to be perfect, you need synchronization between the cache and the system of record. Because we've seen that we read, but we're also putting, and we need to make sure that whatever we put is the latest value that has been seen, because otherwise, if one application thread gets suspended, and it's the one that read the latest value, you can have, or read another value, you can have the latest thread read, write, and then the other one resumes and ends up writing stale data already. So it's not easy. Also, that was not in the list of features. There is no locking option on JSR-107. You can't explicitly, outside of the cache, say, oh, wait, nobody touches that key anymore, it's mine. Sure, you could replace the bit of code I've written by an entry processor. But that also has its challenges, because if you're on heap, probably not a problem. If you've got a distributed cache and that block of code ends up doing database access, are you really gonna serialize or send over the cluster your database connection or something? So it has its own challenges. And clearly, if you need to do that yourself, that's probably a piece of code that has the potential to be hairy pretty fast. So what are your options? First of all, you can say, okay, that's not my problem. I'm going to rely on a framework. And I'm going to use Spring caching or second-level cache of Hibernate. And then I trust these guys to do the right thing. But that's valid when you're in that context. It doesn't help you all the time. So do we have alternatives? Yes, we do. Cache through. So here, this is the exact same logic, except that my cache is responsible for doing the loading of the data in the background if the key was not populated. So this is not an update. The first thing that I was doing was really a get and just trying to fill the cache if the value was not there, which this replaces completely. So the logic there, it's pretty easy. I've got application code, asks something from my cache says, don't have it. I'm going to go ask the database for the data. I'm using database, but it could be your web service that has to compute a lot of data, or just a call that ends up returning a large amount of data. On the opposite side, if you go really full with cache through, you could also have the same logic when you write to the cache. So it's actually your application code that talks to the cache, does the put, and that's it. Then it's the cache which goes on and calls your database system. And so, of course, you can use just the read-through or complete read and write-through, as I've described here. What does it mean? Any get-like operation will use the cache loader. And if the cache misses completely, like my get methods end up returning a null, what it really means is that I had no data. It's like missing row in the database. The usual case, which you can also which you can code properly by not returning null, but that's a different topic. Then every put-like operation will end up calling into the cache writer, which means that when I use that method, I'm actually writing to a system of record and potentially paying the price of the latency this takes. And of course, we've had a great keynote this morning. Guess what? This is no silver bullet either. Yes, it's a more advanced pattern. It resolves a number of problems, but it still means also that you're constrained by the APIs of the cache loader and the cache writer. If these methods to write something take the key and the value and nothing else, you've got to deal with that. There will not be any, oh, I'm going to pass in extra parameters so that when I'm actually getting called from the cache, I can do more magic. No. It's limited to what the API offers. And also, JSR-107 has some peculiar behaviors with regards to the cache through pattern. The put if absent, which takes a key, a value, a Boolean, and a put if absent, as a reminder, it's an if no value, then write what I'm passing you, otherwise, and return null, otherwise return what was in the cache, so that I can continue making my local decision based on the value that was there before I try to write. In the context of JSR-107, it actually ignores the cache loader, meaning if the cache was not populated, it will consider that as no entry, and so will accept the put, but it will actually use the cache writer, which means that if your cache has not been populated, but the entry exists in the database, a put if absent from code will override the entry in the database. We find that a bit peculiar, so what we did in the context of Ehcache 3 is you can tweak this behavior. The JSR-107 service that I've showed you also has a property where you say allow loaders in atomics, and so it will change that behavior. But of course, by default, we're spec compliant, so you get that. Good news, the behavior is consistent across atomic operations. So you will have no surprise. Replace, conditional remove, they all work the same. They don't talk to the loader, but they actually do talk to the writer. This is also a subject of conversation on the mailing list and in the, on the GitHub issues for JSR-107. Any questions? And so who's, yeah.
How we can tell the cache how to access the data? Because you told that the cache will automatically go to database. You get data by the database.
Oh no, okay, so it's the, sorry. It's the cache loader and the cache writer implementation that you pass to it. And when I'm saying constraints, I'm saying you're constrained by the API, but of course, if you have other ways to inject context into the loader and the writer, you're free to use that one. Huh? So yes, so when you configure a cache, it's true that I didn't show that. You can, again, pass, in the context of JSR-107, a factory that will return you a loader or a writer or both. And so that's this code which actually gets called. So you're still writing the data access code. Yeah, sorry, no magic. Any other question? Okay. So one extension of the cache through pattern is actually to add the concept of write behind. And what does write behind provides? Write behind is actually trying to decouple the user thread from the writing to the system of record. Because as we've discussed with cache through, you're actually paying the price of the write each time you put into the cache. And so here, yep, you no longer suffer the latency. Guess what? This is not free either. It introduces its own complexities, and this is one of the fastest way in getting into really, you need to think about your system a whole lot. And as soon also as you introduce advanced topologies on the cache, clearly you need to think about it, and that's also why, as tools or library provider, we try to work on that, and so making their use easy. Because, for example, write queue, should it be persistent or not? What happens? My application said the put was done in the cache, and I'm using cache through, but actually it's not really written up to the point the write queue has been processed. So if it's not persistent and my VM crashes, I may already have informed other VMs of the state change, while actually it's not been propagated. Also, mutation guarantee. In case of crash, what's the guarantee we offer? Once and only once, which means we guarantee you the write will only ever happen once. This is very, very hard. Or maybe at least once, which is easier, but then it means your operation must be idempotent. So if there are repeated invocation of the same update or insert, it should produce the same result. So this makes it probably better for scaling, but forces your code to be smarter. And also, what about cache eviction? One thing that right behind suffers in Ehcache 2x is the entry is in the cache, it's actually in the queue, it got evicted from the cache for whatever reason. When you go read from the cache, what do? A read through the database. But if the value is in the queue, you're actually reading stale value after you've put it, which could be from the same VM, which makes little sense. So in the case of Ehcache 3, what we say is that since we have the value on the queue and it can't be evicted from there, because otherwise it means we are dropping writes, we will not read from the database first. We'll first go see the queue and say, oh, crap, we have an entry to write for that value, so that's the mapping we return. And so, yeah, before we move there, has anyone ever used something other than cache aside and tried to delve into write-through caching? Okay, so that's really little. So it exists. I'm not saying, again, no silver bullet, but it could potentially provide some things for your application. That's it for JSR-107. This is pure Ehcache 3. And yeah, again, interested in hearing reaction either now or after the talk. So the proposition we started with is that a cache level error should not be the cause for a user level error. Because as we've said initially, a cache is a temporary copy of the data, and it's a compromise. Higher memory, lower latency. So if the cache doesn't have the data, or if the cache cannot deserialize the data, why should it crash your application thread? We should just revert to the usual behavior, which means potentially returning null if we're on cache aside, or if we are on a cache through pattern, invoking the reader, the cache loader. So this is ongoing development and subject to change. Small mention. What we do in Ehcache 3 is we handle errors internally as much as possible, with one goal: preserving the consistency of the system. And so everything where we can recover internally, you won't see an exception. We'll either return you null, saying we didn't find a mapping, or we'll invoke the necessary stuff to return the proper mapping. But in the end, when the cache method returns, the cache is clean, in the sense that it doesn't contain data which is not in sync with the underlying system of record, if we know about that. So that's a cache through case, for example. So for example, in memory, no, there should not be any problem because, yeah, I mean, if it's a pure in-memory cache, when you stop the VM, nothing is left. When you start again the VM, even if the classes that you put in the cache have changed, since we're not getting them from a different source, there is no reason we should have exceptions. And so what we will default to is logging, because you or your operations team might still be interested in the fact that the cache is no longer working, because this may have a performance impact on your application. And we aim also for that to be configurable, replaceable. You may have cases where you say, oh crap, if the cache is not working, I want an exception to be thrown, because I'm handling that at a higher level. Fine. We can't decide that for you. It's your application logic. And then we've got advanced setups. So if you've got a distributed cache plus write behind, there you can go in problems where if we can't clean up the cache, if we're not sure if the write happened, we can go in a place where we say, okay, sorry guys, but we have no idea if the system is still consistent. And so instead of throwing an exception in that case, exception which would need to be runtime, because otherwise you will see them always on the APIs of the cache. So if it's runtime, it probably will get ignored. What we want to do there is force the user to think about the use case by telling them you've just configured a distributed cache with write behind without giving us a resilient strategy implementation. Sorry, not acceptable. We expect you to provide us implementation of an API which will be called when the cache gets into a state where we say, we don't know what to do anymore. Maybe you know. And maybe in your business use case, you indeed know what to do. Maybe indeed you don't either, and then it's just the node needs to die and be restarted. And so yeah, you'll be required to configure a handler for these cases. Any questions on that? Yeah.
When we were in need for a cache, we just kind of grabbed what was the closest thing. It was Guava caching. And can you tell, I don't know, what would be the reason to consider migrating on Ehcache? Like, at what moment we should start thinking about migrating from Guava to Ehcache?
Okay, can I answer that in 2 minutes or now if there are no other questions? Because I think the rest is going to be of interest for that specific. Okay, then moving on, but answering you. So a little bit about Ehcache 3 and Terracotta, because we've had some news over the last months. So the first one is Ehcache 3 comes with an off-heap solution. So for free in the open source version, it's actually available in the milestone 1 that was released in April and will be still in the milestone 2 and the future. You can use off-heap storage, which solves the garbage collector poses on large heaps. Because then what you can say is my VM is 4 to 6 gig, my machine is 32 gig of RAM, so my caching space is 20 gig on the side. And then it's off-heap. The GC will not touch it. It's managed by our own implementation. It doesn't add anything, and you can have 20 gig in the same VM. So that would be one of the reasons. Guava caching doesn't have such scaling options. A bit of bragging, I guess. We go to multi-terabytes. So the biggest machines today have 6 terabytes, and so we've done tests on that, and we scale to that point. So we've got a 6 gig VM, 6 terabytes of data on a single node. You probably don't want that to be your model. That's probably extreme scale up. You probably want to also scale out a bit, because if that node goes down, just reloading that amount of data is going to be problematic. It's the kind of things where just loading the 6 terabytes of data takes hours, whatever you do. And so, yeah, what we've open sourced is the production tested implementation that was enterprise before. So it's really there. It's available also as a library. Probably lacks documentation to be really used, but if you're hardcore and want to look into it, you can go see the code. By the way, no unsafe. So whatever happens in JDK 9, this is not impacted. We don't use unsafe at all. And the second thing is the clustering solution. So clustering, sharing of data across multiple JVMs. Terracotta 4.3, which is Ehcache 2.10 compatible, as again an open source offering with regards to clustering. You can have a single Stripe cluster with multiple passives for high availability. And of course, since this is available in 4.3 with Ehcache 2.10, it will be available in the next iteration of the Terracotta platform for Ehcache 3. And so that's also one reason you may want to move to Ehcache, is that you can not only scale up, but also scale out by clustering your caches. And yeah, that's ongoing code. If you look at some of the forks on GitHub, you'll see initial code for that. So that's ongoing work to get that into Ehcache 3. And that's it.
I have a question.
Yes?
Getting back to handling exceptions. So what will be done if you met exception during write behind? So you write something behind to database, and you have some error because database is not accessible. And how Ehcache will
Yep.
handle that.
Okay. So the question is about write behind and potential failures when writing from the queue. So there, when you configure write behind, you can tell it to retry a number of times with some delay in between each retries. So that's purely a control of the write behind operation. Yeah.
Question.
Yep.
Can you apply the caching somehow declaratively to the methods, not invoking explicitly the cache operations?
So JSR-107 has that option through annotations. We have no plan on doing that specifically for Ehcache 3. I think when we go declarative, just having a standard that offers that is more than enough. Spring has also an abstraction that uses annotations. They're actually starting to fold back on the JSR-107 annotations, or at least they support them too. That's probably a better way of saying it. So yes, you have these options for doing that. Okay, thank you. Enjoy your conference.